Hey guys, in this episode, we dive into the world of paleontology. Our special guest, Thomas Carr, a distinguished paleontologist from Carthage College in Kenosha, Wisconsin, takes us on a journey through his work at the Dinosaur Museum and his research of these ancient vertebrates, particularly the family tree of Tyrannosaurus Rex. Our conversation begins by delving into Thomas's early childhood fascination with dinosaurs, a fascination shared by countless children around the world. We explore how dinosaurs, with their mysterious allure, ignite our imaginations and have served as the inspiration behind blockbuster movies like Jurassic Park and Jurassic World. Thomas sheds light on how these movies have not only entertained audiences, but also how they have influenced the field of paleontology. As the interview unfolds, we discover the profound importance of studying dinosaurs in relation to evolution, climate change, and planetary biology. Thomas enlightens us on the pivotal role dinosaurs play in unraveling the mysteries of Earth's history, and how their study provides valuable insights into the evolution of life both on and off our planet. One of the striking aspects of our discussion is his emphasis on understanding how dinosaurs lived, rather than solely focusing on how they died. Throughout the episode, we are reminded of the inherent truth-seeking nature of the natural sciences, and how this principle guides Thomas's work as a paleontologist and teacher. So come join us on this journey as we delve into the captivating world of paleontology. Discover how these ancient giants continue to inspire our curiosity, ignite our imaginations, and shape our understanding of the natural world. So we're here today with Thomas Carr. He is a paleontologist. So tell us about yourself. Who are you? What do you do?
I'm a vertebrate paleontologist, first and foremost, so I study the evolution and growth of Tyrannosaurus Rex and its closest relatives. That's been the mainstay of my research career since 1999. And my day job is an associate professor of biology at Carthage College, and there I lead a paleontology program.
Yeah, that's awesome. I just think it's so interesting that Carthage, such a small school right on the lake, Lake Michigan, has a paleontology program. I always thought that was fun. We are currently sitting in the main hall of the Dinosaur Museum, and it's pretty cool.
Staring a T-Rex right in the face.
Yeah, and you said you're all about the T-Rex.
Yeah, so I guess a couple things. The first is that the whole concept of a dinosaur museum and a paleo program was the brainchild of Mayor Antaramian and President Greg Campbell at the time. And so I was hired to basically get this thing moving. And in very short order, we had the gallery designed. I interviewed, I think sometime in 2003 or 2004, and I saw the space, and I immediately knew what I wanted to do with it. And so what you're looking at is a story, and it's the story of the evolution of birds through meat-eating dinosaurs. We know that living birds are literally living dinosaurs, and they're descended from meat-eating or theropod dinosaurs. And so I wanted to show that entire history of theropod evolution. That's technically what meat-eaters are called, and culminating in birds. So when people walk in the door here, the first thing they see is Herrerasaurus, which is an early dinosaur, and it's sitting down. I wanted to show the public behaviors and postures that dinosaurs would have done as animals, so they aren't all just standing there, yelling.
Yeah.
And so Herrerasaurus shows people how a dinosaur would have sat. And then next to that is Eoraptor, which is running after an imaginary insect. Right opposite us here is Carnotaurus, which is a very imposing animal featured in Disney's Dinosaur and also in Jurassic World as well. Fairly well known in pop culture. And this is one of the few Carnotaurus skeletons that are actually shown in a run. So I wanted to show off just how active these animals really were. A couple other things with the gallery is you'll notice that some of the skeletons have their bones painted black, and other bones are natural fossil color. And that's intentional. I wanted to show the public exactly how complete or incomplete the various fossils are. And so every bone that is reconstructed and doesn't exist in nature, I had painted black. So at a glance, people can see how complete or incomplete a skeleton really is. And so what I wanted to do was maximize the information content of the gallery beyond what most museums usually do.
One thing you mentioned that you've been involved in this since 1999, you said?
I've been publishing on Tyrannosaurus since then. So I started working at Carthage in August 2004. And so it was a pretty rapid process from, applying for the position, interviewing, and to acceptance, and then starting here.
Yeah.
And what do you feel, what was it that led you into this field? Was it something rooted in childhood, or was this just always a fascination of yours?
Yeah, well, according to my mother, my interest in dinosaurs started when I was 2, and that was based on just kids' books on dinosaurs. And so when I was little, we lived briefly in London, so I saw a natural history museum there. I probably saw dinosaurs. What I remember most is the blue whale in their Hall of Mammals, which is still there. I got a chance to see it again a few years ago. And then we moved back in the vicinity of Toronto with the Royal Ontario Museum. So the spark was with books. I latched onto it. And when I became about 16 or 18, that interest came of age. And so I took a more academic, active interest. And in 1986, I volunteered to dig dinosaurs with the Tyrrell Museum, when it was then called the Tyrrell Museum of Paleontology in Alberta. And so in 86 and 87, I dug up dinosaurs and then started volunteering in the Paleo Lab at the Royal Ontario Museum. And so that locked things in.
I was going to say, would you say that probably sealed the deal, where, it was a curiosity, it was an interest, and then all of a sudden actually physically digging it up was just, okay, this is what I want to do.
It was more of more of a fixation as a kid. I think a lot of kids go through that, but interests do come of age. Like, I realized there is a lot to learn here, and the avenue to learn about these lost animals, these extinct animals, is through the medium of science or the method of science. And so there was no turning back, especially in 86. The way the Tyrrell Museum had set up their field camps was all this took place in Dinosaur Provincial Park, which is a UNESCO World Heritage Site. And they had a bunch of trailers. So sleeping trailers, shower trailers, kitchen trailer. And just one evening, 18 years old, I was walking from my trailer toward the kitchen trailer. And those stereo vision things where you put in the cards, and they have 2 pictures, and you have to adjust your eyes, and the images overlap. And mentally, it was kind of like that. It was like my view of my entire life suddenly crystallized in a moment, and I realized I had arrived.
That was your sign from the universe.
Well, it was just a realization that I found my place.
Yeah.
But the next step is actually making that happen. And that's a lot of hard work. And that's something that my paleo students are discovering now. Is this, to become a professional scientist takes a real commitment to training, and it's not an easy road.
Yeah, because one of my curiosities is what separates, because, I think back even when I was a kid, I don't know of any kids that aren't fascinated by dinosaurs. Jeannie herself has a 7-year-old, and he's been into dinosaurs.
Yeah, T-Rex.
And still is. And I feel like every kid is at some point. I don't recall
for sure.
any. Maybe there's some kids that aren't, but it seems like that's like an enduring fascination for every child. I've always been fascinated by them. I love them as a kid and learning about them, but I didn't pursue, a career in it. So that's what I'm wondering. What is it that, draws
Made you
somebody,
want to go
draws
further
draws
with it.
somebody into versus just the fact that everybody's interested in it, but what separates, the individual that decides this is what I want to, work on throughout my life. This is what I want to study and research and learn more about. So
It's a good question. I don't think there's an easy answer, for any, profession or, interests that people have that they pursue. It's all individual. And certainly our culture offers, a fairly wide variety of things for people to take interest in. And I guess it depends on early exposure. So I think early childhood is probably pretty important. Individual neurochemistry, I think, is part of it. So it's context. It's, social, cultural, neurochemical context as well. And I think all that weighs in. But you're right, kids do tend to go through a dinosaur fixation. They not all of them do. Many do. And then only a vanishingly small proportion of those go on to the science. Then we have a lot of paleontologists who had no interest in dinosaurs at all, but later down the road they, fall into working on them for one reason or another, depending on where their research program takes them. So there isn't, I think, a single typical pathway toward, that would explain all vertebrate paleontologists that study dinosaurs.
And when would you say was the transition into instructing and teaching in the field versus just researching or doing, work in the field? Or has that been
Or do
since
they
the
go
beginning?
hand in hand?
Yeah.
Like in general, for people, or
No,
For you.
Oh, in
for
my
you,
case.
like when you, kind of transitioned into becoming an instructor,
Right.
and
That basically came with the job. So the job was to start this program, instructing comparative anatomy of the vertebrates. That's sort of one of the foundational undergraduate courses for vert paleo in many cases.
wow. What do you feel that it has been a kind of the more rewarding side of it is, helping others learn about everything in this field and then watching them kind of go on to make their own discoveries and turn around and kind of launch into their own careers in it?
Yeah, it's really great to have a hand in that. We had a UW Milwaukee student who took a couple of my classes at Carthage because we offered things that they didn't offer. And he's now the curator of the Weiss Earth Sciences Museum up at UW Oshkosh, Fox Valley. And one of our students, one of our alums, is a PhD student in New York at the Richard Gilder Graduate School. And she's studying the evolution of mosasaurs, so marine reptiles, and is involved in a lot of really interesting projects that she's actually been invited on. So it's really great to see students fledge in that way.
Yeah. And, go ahead.
Oh, I was going to bring up the influence of Jurassic Park. I bet you have some stories and thoughts about that. Did a bunch of students rush in after all the movies came out, or how has that impacted, do you think, the way you teach?
Yeah, it's kind of variable. For me, obviously, Jurassic Park actually was kind of important. I think I was in undergrad or doing a master's at the time Jurassic Park came out. And it was really important personally, just as sort of a validation of the interest. I saw that damn movie 9 times in a week. And I went with my parents separately, and almost as a demonstration of, see, this is something that's interesting and worthwhile, has cultural traction, yada, yada. But I'm not of the generation that was influenced by Jurassic Park to enter the field.
Yeah, you were before that.
And that's actually people who are professional scientists now. So Jurassic Park itself really has no relevance to current students, but the later movies do. So Jurassic World, so I have students come in that are more familiar with Jurassic World, the movies there, than the initial three. But yeah, it's undeniable that that whole franchise has had a real influence on students. We've seen, I think, a burst of interest of students in vertebrate paleontology, in particular dinosaurs. It's quite competitive out there because of that, and that is why our program is structured the way it is. So we want to train students in the three legs of the stool for being competitive candidates for grad school, and the legs are these lab experience, field experience, and research.
So the thing I was thinking about was obviously Hollywood and media can more sensationalize some of these things, like Jurassic Park, for example. I'm sure there's things in those movies where it's like, yeah, that probably wasn't accurate, or that probably wouldn't be the case. But do you think it ultimately still is a good thing that although there's fiction there, or there's inaccuracy, or there could be potential inaccuracies, that it's still a good thing that it gets people interested and excited about it?
And I guess I'm kind of ambivalent about that. The hardcore kids already know all the inaccuracies. When they're really into it, they figure that out or discover critiques really quickly. I think it's sort of a double-edged sword. So, we've got the movies, we have that presence in the culture, we have that stirred up that interest, that's good for science. On the other hand, it's made dinosaurs a bit into commodities, and one real problem that's cropped up over the past decade is auctions of real dinosaur skeletons. And that really hurts science because we really don't know much about dinosaurs at all because we have so few examples of individual animals. Like Carnotaurus is still known from only one specimen, and we've known about it since 1987. Wow. I mean, that's it. And could you imagine if, another Carnotaurus was found but wound up on the auction block? So we'd lose all that information because, these skeletons are of individual animals. They're a snapshot in time of the overall biology of these creatures. And of dinosaurs, T-Rex has been really hit hard. Over half the sample size is in commercial or private hands. Those can't be studied by scientists. Also, half the juveniles are in private hands as well. So that's become a real problem. One thing that interested me was in, I think, Jurassic World Dominion, the second one, where they had the auctions of the actual living dinosaurs. And I thought that was pretty interesting. It seemed to show some awareness of the problems that we face as scientists, like literally hemorrhaging our sample sizes to the market. I can't see how it could not be an influence. But, overall, I think it's generally good for science. I don't think the inaccuracies are good. So for example, in Jurassic Park, we have Dilophosaurus, which is actually fairly large flesh eater, was shown spitting like a black pitch or a venom, and also with a frill, a cowl around its neck. And neither of those things are true. And what that does to us as scientists is then we're in a position to have to explain that that's wrong, and here's why. And since people have seen it in the film, they assume the film's right. And so we get the gaze of skepticism. And it's just so much more work for us to do. There's a bit more effort that has to be put into sort of clarifying things. And so I wish that Hollywood would put a bit more work into getting the science right, because it does, make these little ripples that, I think are counterproductive. It's easy, the last thing I'll say about it is it's easy to get dinosaurs right. We know enough about their anatomy not to flub them, and yet they're intentionally, it seems, they have flaws, and that's just inexplicable to me.
And it seems like new discoveries are happening at a pretty breakneck pace. I mean, I'm kind of thinking back. I'm no expert, but I just remember learning about them as a kid, and there wasn't talk of them being likely covered in feathers. But then I feel that that's more of a contemporary realization is that they may have been a lot more species may have been covered in feathers than we originally thought. So I feel there's a lot of that going on too, that every day, every year, there's new discoveries out there that are maybe setting new precedents or moving around time frames even, and just biological facts of certain species and new species being found. So I think it's hard to, I guess it would be hard to make a movie like that.
I think dinosaurs in general, they just trigger your imagination. Like when you walk into some place like this and you just see the skeleton, I mean, me being an artist, my mind, wants to flesh it out. Like I want to draw, I want to see how they actually looked. So I think Hollywood, might run a little wild with that. Want to make it look super cool, and their imagination runs wild. But I think that's also what dinosaurs do. Do you agree? They just inspire you to, triggers your imagination. You got to think about like how they acted and what they looked like and all that.
Yeah, and I'm actually teaching my dinosaur evolution course right now. And for the second lab, I've had students take on the task of various soft tissue structures, sort of getting at, what do dinosaurs look like really? And so one student is taking on the question of whether or not dinosaurs had cheeks. Another one's taking on whether or not they had lips. Another one is investigating what their tongues might have looked like. Another is examining what the scales on their feet and toes might have looked like. And there's a very formal approach to framing those questions and assessing the data and setting what's called a null hypothesis, a hypothesis of no difference. And so it'll be interesting to see what they come up with.
With a lot of this show being concerned about the deeper meanings of things, it's obvious studying dinosaurs is important. We all know that, but what would you say to the person that's asking, well, yeah, I know it's important, but why is it important? And we touched on this in the concept of archaeology with
The mammoth episode.
with Dan, and he tied a lot into understanding climate change. But what do you feel are one of the most important things that can be learned as a result of understanding these extinct creatures and learning what their biology is and learning how they behaved and how they function? What other doors can that open?
Well, the bottom line is that this Earth has an incredibly long history. It's about 4.6 billion years old. Life arose very quickly on the heels of the planet cooling around, somewhere between 4.5 and 3.8 billion years, cellular life evolved. And so dinosaurs are part of the grand history of life on Earth before people evolved. And those basic facts can be established. We're not making anything up here. We have the bones, we have the rocks, we also have the isotopes that can tell us how old those rocks are really. And so we can, with that information, establish the facts of the history of this planet before people arose. The second part of it is that, is shown by this gallery, is that there's continuity from the origin of life to all the diversity that we see on the planet today. And so theropods are one particular lineage. They're connected by descent. So this is the insight that Darwin had back in 1859, that every species alive today is connected to all others through descent with modification. That's just the endless chain of ancestors to descendants. And with the influence of natural selection, sort of tweaking the ancestral form into different descendants. So we see the fact of evolution here as well. So dinosaurs are really important for establishing the pattern of their own evolutionary history, which is a model for people to learn about and understand. They're, and for the public and for students, dinosaurs are, as we've established, they're charismatic, they're interesting, they're beautiful. And along for the ride is a very fundamental story about evolution and about how we're a product of that as well. And also, I guess the third strand of it is that paleontology and dinosaurs enrich people's lives. They're interesting, they're engaging, people want to draw them or sculpt them, want to know what they looked like, want to know more. And for science education, that's great. You know, dinosaurs are a very substantial way of attracting people to the sciences, particularly biology. But dinosaurs also lead to other considerations like physics, the physical sciences. So kids who are interested in that sort of thing, you know, can pursue like functional morphology, it's called. So dinosaurs are a very rich source of intellectual intrigue and enterprise and productivity. And they also serve, you know, the larger culture in terms of education about science.
Yeah, because that's, I know one of the things we're digging at is again kind of the question of, you know, how can understanding dinosaurs inform us of our modern times, or, you know, what can it help us learn about the world as it is today, or how can it or by, like kind of a filling in the blank of by understanding dinosaurs we can also understand, you know, again, just going at those deeper understandings of things.
Certainly, toward the end of the dinosaurian world, the climate did warm up. We know that for North America in particular, there was sort of a subtropical to tropical transition in the last 300,000 years at the age of dinosaurs before the asteroid hit. And so, you know, we can study the big picture of, you know, dinosaur ecology to learn about the effect of, you know, relatively rapid but local climate change, that sort of thing. So there is that sort of utility there, and in fact, you know, that's part of the objective of studying the field areas to actually see if we also can track that warming. And it looks like, you know, based on our field work, that we found palm trees that are sort of high up in the rocks toward the extinction. It looks like our area might capture that signal too. That's also seen in North Dakota and northern Montana. I think fundamentally, the study of dinosaurs is part of the larger study of, you know, planetary biology, and sort of the greater lesson that sort of extends from the scientific method, right? So the scientific method is the only form of knowledge that seeks to destroy its own claims. So in science, we test hypotheses. And when you do that, you carve away a lot of garbage. You just clean that out pretty quickly. And then we arrive at a very narrow set of problems that remain. And what's pretty clear is that the scientific method has shown that in terms of the history of the universe, including the history of Earth and our solar system, is that there's a single history of the universe. There aren't multiple histories riding and overlapping each other. There's a single history, ergo there's only one truth. And the only way to arrive at that is the scientific method, right? Because we rigorously are trying to undermine our own claims until we can't anymore. And I think paleontology and all the other natural sciences that sort of study the historical aspects of science, you know, like astronomy, I think even, you know, organic chemistry, geology, are all part of that project, is uncovering what really happened in the history of the universe. And we have the tool to uncover that and, you know, dispose of all the alternates that have no supporting evidence.
Yeah, and to think that creatures like this that were the apex predators of the planet, that you look at them and just, you know, looking at their skeletons, it's just, wow, how could something like this have been wiped out? So I think they do represent an inherent I don't know, caution for our own species to think, like, if these beings could be just wiped out, then maybe we should start to consider, how vulnerable we are or how vulnerable we're making ourselves. And I kind of feel that is one of the things that maybe not a lot of people think. It's obvious. It's, we all know, dinosaurs aren't around anymore. But I think they represent, I don't know, maybe it's not that they engineered their own demise. Again, they couldn't control that something crashed into the earth. But again, I think it presents a good cautionary tale or concern that, while humanity is the dominant being of the planet, doesn't mean that we're invulnerable or invincible, and perhaps we should think about a little bit more what's going on in the world, or what we're doing. I don't know what your thoughts are on that, but
Yeah, it's dinosaurs. Since I'm so focused on understanding how they lived, I don't really pay much attention to how most of them died out. I think that the main lesson of the KPG event, which is what the extinction is technically called, is that we really have to pay attention to our immediate environment in the solar system, and we are doing that. We are monitoring asteroids, and particularly asteroids and comets that might potentially cross the orbital pathway of Earth. I think that's really where the focus should be, and we've seen some really important things happen. A little while ago, NASA collided a little satellite with an asteroid to see if it would change its direction, and it did. And so people are thinking of planetary defense, and people ought to, because we've seen how catastrophic it can be. For the KPG, over 70% of life on the planet died. It was, worse in the seas than on land. And, I have colleagues who think dinosaurs are important for understanding relatively rapid climate change. Certainly the climate change that we're seeing now is nothing like we've seen before in the fossil record. It's, it's galloping far more quickly than anything that's ever been seen. So there is some relevance there too. So I agree with that. But I think dinosaurs are important for considering Earth and Earth history in that larger solar context.
kind of leads into another question we definitely like to ask is what do you feel are some of the most important kind of cutting edge studies being done right now, or something? What's your latest in pursuit, or what is the project that you're most involved in at the moment?
Well, there's so much. It's hard to really pin anything down. There's new discoveries of new animals all the time, new dinosaurs and other extinct animals. I've been lucky enough to have been involved in studying a few of those. In terms of my own focus, I'm working on a project recovering the family tree of Tyrannosaurs. And so I published on that with a colleague back in 2016, and it's time for an update because so many new things have been found. The data set's been growing.
In just 6-7 years.
Yeah, and so we need to update that, which is pretty important. I just submitted an article writing up a Tyrannosaur leg that was found in China in the 1920s. And so a lot of the old fossils, or fossils that were collected, early 20th century, require a second look given new knowledge. And so that should be published in a few months. I just sent in the revised version a few weeks ago, and it seems like it's getting close to the runway for publication. And I'm also working on a big description of a juvenile T-Rex nicknamed Jane, which is on display at the Burpee Museum in Rockford. And I inherited the project of writing it up. So a big part of what paleontologists do is just anatomical description. There's a lot of information that every single bone has. And Jane's a fairly young Rex, and so there's a lot of information that we've never seen before for an animal that young, because the young ones are really different from the adults, which are massive and very different in many ways, at the start of a golden age.
Oh, it's only it's great. And that's only a good thing. So
Yeah, it is.
I want to switch gears a little bit to teaching, the teaching part. So you teach college. Have you ever taught at the museums?
I've led some public programs, so I've done some gallery tours, and I've done presentations of our field work and research to a public audience. I've been asked to do talks at other museums, public talks, and I've also done a number of graduate seminars. I go to the Museum of the Rockies quite frequently to do collections research there, and I'm usually asked to lead a seminar on a particular paleo topic.
Do you see a difference between teaching like in a college classroom and teaching like seminars at a museum?
Yeah, so for a public audience, things are very general, not specialized. For a graduate seminar, things get pretty heavy pretty fast. So very technical, very focused on, say, a particular problem. I might even have a group of students, do an exercise, gathering data and, analyzing it in a straightforward way. So yeah, there is a big difference. There's different needs being met there.
I like to just ask everybody this question is, do you have any sort of like a dream location or a dream thing you would love to find? I mean, I'm sure just any find of, I'm sure a fully preserved Tyrannosaurus skeleton, but I mean, do you have a location or a specific type of just if, like your dream study sort of thing?
Yeah, there's a couple, and one of them might have been found last summer. So our field area is fairly extensive, and there's areas that we haven't been to, and so we went to a new area last year, and one of my volunteers radioed me and said, Dr. Carr, I found these bones, I don't have any glue or anything. What do I do? And I said, well, photograph them in place and put them in a bag. And my volunteer was on that hill for a long time. And I was wondering, why is he still on that hill? And it wasn't until much later in the day after dinner that he brought out this gallon bag, Ziploc bag of fragments. And I thought, oh boy, here we go. And so when dinosaurs weather out, the bone immediately breaks and falls apart. And so usually what we're picking up are fragments, and then those might lead to a skeleton or a bone underground. And so I started pulling out bits, and the first bit I pulled out, I thought, geez, this really looks like the end of a juvenile T-Rex tibia. I didn't say anything. I put it on a table. I put my hand in again, pulled out another piece of the ankle end of the shin bone of a young T-Rex. And then I started pulling things out more earnestly. And in the space of about 5 minutes, I had a pile of shin bone fragments from both tibia and fibula. That's the technical names for them. And a bit of a vertebra, a bit of snout, and one or two other things. And so all these fragments were from one location, one small spot on the side of the hill. They were all the same species and all roughly the same size, which means that Mason had picked up a juvenile T-Rex skeleton that was actively weathering out. Now, that was on the second last day of our field season, and we were in a very remote area. There was no going back. We had things to do on our last day to close up most of our quarries and stuff. And so, it's a 2-year wait because we have 23 off and then we go back out in 24. So I can wait. The erosional rates aren't that high, and we'll go and see if there's a skeleton there. That's the bottom
kind of dying
line.
to get back there.
You have to, I want to get back there, but, you just have to roll the punch of the wait. But here's the other part of it, is that we don't know if Mason was too late for it. It could very well be that was the last bits to be exposed and weather away. However, The ankle bones he brought back were not bleached by the sun. They're still this gorgeous chocolate brown, and they had just been exposed by erosion. So that's a positive indication that maybe, just maybe, there's more in the ground. How much, there's no way of really knowing. So I view it as Schrodinger's T-Rex. It's both there and not there.
Yeah, it just sounds like you really have to enjoy puzzles to be doing something like that. And coming back,
Yeah.
the only time I'm going to speak on what I do, I actually own escape rooms and build,
Cool.
escape rooms. So I'm a very puzzle-oriented person.
Yeah.
And you saying finding all those different fragments and having to figure out how they go together just reminded me of.
Like an unfinished jigsaw puzzle would drive you
Yeah.
nuts.
Yeah.
But I think that would be intriguing for me. Is like, no, I got to figure out how it all fits together, and what am I looking at here? What is this? How much am I missing? How much do I have? I guess it'd be kind of maddening because it might be a puzzle without all the pieces there. So you're having to kind of infer a lot more and kind of think of the pieces that aren't there too.
Right. So Brady, who you met earlier, has done a really great job of piecing together the bag of fragments. So I think we've pieced together everything that we possibly can. And of course, there's a lot of little bits that don't have a home yet. But the important part is that we have a small animal that is definitely T-Rex. We know that based on the snout bones and the ankle. And it's a juvenile, and juveniles are very rare. There's only a handful of other specimens in museums. There's only 5 or 6. And this one is smaller than Jane, so this one is probably less than 20 feet long. And we know that because we can actually measure some of the bones that we do have of our juvenile. So this will be a very important window on the early biology of T-Rex. And in fact, there's some of the bones are complete enough to have included in that update of that Chinese Tyrannosaur leg. So it's actually going to be in the literature now. And that's sort of the best possible outcome for a dinosaur specimen is to be documented in the scientific literature that, that we're actually getting useful data, informative data from the bones that increases our understanding of, growth or evolution or whatever the case may be.
What is something, because I know we want to keep touching on the instructive aspect of this, regardless of if you have a student that launches into a career in paleontology or some other related field, or whether they're just somebody taking the course because they're kind of interested, it's more exploratory for them. What are some of the things, or if there's a one thing that you would hope they take away from it, that you could instill on them, even if they don't, again, go forward into a career with it? Do you have any of those, anything like that if you take one thing away from this class sort of thing?
I think the important thing is the values and ethics of science, is that we're here to report honestly about the world. We're trained not to lie. And I think that's the single most important lesson, I think, across all the sciences and in a rigorous way.
Kind of ultimately, seek truth and try to establish fact versus, and like you said, just, being honest and trying to find the truth of something, whether it's a historical truth or
I like the idea of being trained not to lie.
Yeah, that's actually a phrase that one of my colleagues used. That's not mine. So, okay. But it's important. I think that really puts in a sharp focus what scientists in general are up to. And it's hard. I've got, for this soft tissue project, it's challenging because some students might already have their own idea of some particular feature, and they have to basically get a leash on that and set that aside and follow the method. And that's hard. That takes a lot of discipline and fortitude. Science isn't easy. Like, just the basic method isn't intuitive because there are things that we want things to be a certain way.
Yeah, you kind of try to want to try to prove a specific thing, even
Using
though that
logic.
might not be it. But again, like you said, trying to put those subjective things aside and be totally objective and say, well, I don't know what I'm going to find.
Right.
Yeah,
Right.
that's a good point. I
That's
like
really critical, and that's the point I try to emphasize is we don't already know what the answer is. I'll have other students who will panic and say, I don't know, how to, whether I even should approach this. And, the answer is, well, take a stab at it, see what the hypothesis is. It doesn't matter. You don't need to already know everything. You don't already know everything. And scientists proceed with the knowledge that they don't, and that's why the tools of science are available to arrive at answers that are supported by data. It's funny that you use the word prove, and that's one of the forbidden words. I'm not shaming you. It's actually deliberate. It's in the syllabus, so words not to use in lab reports or their term paper is prove is there and its derivatives. Because in science, we never prove anything. We're testing hypotheses and we're proposing hypotheses. And as solid as an hypothesis may be, tomorrow we might have data that overturn it. Mm-hmm. But we do know that in and of itself is a historical process. So those hypotheses that survive testing become theories. And so theory of relativity, theory of evolution, every single challenge that's been thrown at those has failed. So we know we have something that is a tier above a hypothesis, right? It's consistent with all the available evidence and explains and predicts things. Then the tier above that are laws. So there's physical laws. Generally, that's physics occupies that domain.
I think too, we touched, I think this will be like our last thing, but I like the idea of time. You brought up time. We're basically studying time. Any thoughts you want to share about time and your study of dinosaurs?
I guess in a larger sense, time is sort of a sobering thing when we think about the possibility of life elsewhere in the galaxy and in other galaxies. There is basically almost a perfect continuity between interstellar material and organic chemistry, so the prerequisites required for self-replicating molecules like RNA, and then that, and under the influence of natural selection, we get DNA and cells and stuff. Well, the funny thing about Earth is that most of Earth history was just algae and things like algae and bacteria for over almost 2 billion years. And what that means is that complex multicellular life, like we are and like dinosaurs, isn't really all that inevitable. Multicellularity did evolve multiple times across multiple lineages, but it took a hell of a long time to get there, billions of years. And what's really exciting about what's happening with the rovers on Mars is just a couple months ago, I think the rover Opportunity snapped a picture of fossil water ripples. Mm-hmm. And that just, to my mind, was the most amazing thing because, I think that's our Earthrise photograph. Because I think for the public, it brings home the fact that there was, Mars was at one time a watery world. It wasn't that way for long. Possibly it was warm enough for life to get kick-started there too. And that sort of sets our expectations of what we would find on other planets. And so the earliest fossils on Earth, or complicated fossils, are things called stromatolites, or these layered rocks produced by various types of colonial algae. And so, if we do send people there to look for fossils on Mars, maybe that's the sort of thing that we should expect. And we shouldn't necessarily expect complex life like this to be all that probable. I know that some exobiologists are eyeing, Jovian and Saturnian moons, the icy ones like Enceladus, for possibility of life in their, subsurface oceans. And so I think time is important in terms of setting our expectations for the history of life elsewhere outside of Earth. But time will tell.
Perfect.
Yeah, it's very interesting to think that, paleontology could be something that's utilized off planet, and other places in the solar system, which is wild to think about. But who knows? Be fascinating to get there in our lifetime. But
Time will tell.
yeah,
So
No pun intended.
if you could recommend one homework assignment for everybody, what would you want us to do or take away from this lesson?
Dinosaurs are very visual, and why not take advantage of that? And I think learning the names of the parts is a worthwhile exercise.
Yeah.
It just makes them more interesting.
For sure.
Yeah.
All right. Well, thank you again for talking with us today.
Well, thank you for inviting me.
This was so cool. Still looking at the T-Rex over there.
well, I could just talk about this for
Ever.
hours on end, but obviously we got to keep it somewhat concise. We went a little bit longer than.
Expected. But that's good. So, for this podcast.
And yeah, we thank you so much for taking the time out of your morning to talk with us about all this.
Thanks for having me. It's been a pleasure.
Esoteric Mammoth. If you would like to learn more about our podcast, its guests, and how to get involved, please visit our Patreon, linked in the description below. We would love to hear how your homework assignments went, and if you know of any educators who would love to be on the show, please send us a message. Until next time.